Today, I would be talking about the object-oriented programming. And for today's RStats presentation, I'm going to be talking about S3 and S4 systems that present in the OOPS, like the object-oriented programming. And so the outline for today's presentation, I would be talking a bit about object-oriented programming, the story behind the S3 and S4, like starting from S to R, a little bit story about it, different object types, and then features of S3 and S4s. And along with this, I would be showing some demo, like we will be going through some R demo script as well. So object-oriented programming, this is the programming technique that manages the complexity of a program more efficiently. And then the need for object-oriented programming is to organize the code well, to reuse, and to maintain the code following the modular approach. So here on the left-hand side, bottom left-hand side, is the major component of object-oriented programming, which is a class. It's also like the blueprint of it's like a blueprint, like a prototype, and then object is an instance of a class. So for example, if we want to define a class, say for a car, like what properties it has, what color it should be, what should be the price, the kilometer, the model of the car, and methods, which is like the functions of the class. These tell us about, like, here we can define the behavior of like the car that we want. We can define the methods like for starting, going backward, forward, and stopping. And then the object, which is the instance of this car class. For example, the property values could be like you're talking the car should be of like red color, the what should be the price, kilometers, how many kilometers it has traveled, what model you want, like say Audi. And then for the methods, it's the same. The behavior of the car is going to be the same, like defining start, backward, forward, and stop. So, like along with this being the major component of object-oriented programming, the class and the object, there are the four major principles that it works on, which is abstraction. Like we just want to know the behavior of the object instances for all the classes and the prototypes. Inheritance is like deriving the properties and methods from one class to another. There is encapsulation where we want to protect our data. We want to group the properties and the methods into classes and the prototypes. And then there is polymorphism, the ability of objects to take on different type or present as a different type. So having having this background, like the object-oriented programming versus functional programming, R supports both of these, where functional programming is like a programming where we focus more on functions to transform our data, and object-oriented programming is more of modular structure that focuses on objects and carries the data and behavior. For example, sum. This is a sum of, like, we want to look at the sum of numbers 1, 2, 3, 4. And then this is going to be like a function that operates on the data. So this is kind of a functional programming, whereas print lm, like the lm function, this is a method behavior that depends on the object class. So why we are talking about the object-oriented programming more is because it powers the base R. It's more convenient for statistical modeling and large frameworks like the packages that we work with from Bioconductor. Next, so diving into the story behind S4, and R. So R language is historically derived from the statistical language S that was developed at Bell's lab. And R later on adopted these object-oriented programming systems from S. So that is why the names S3 and S4 are being carried forward. There is also, apart from S3 and S4, there are other reference classes called as the R5, R6, and now there's even 7. But S3 and S4 remain foundational, and these are heavily used, especially in the work in the bioinformatics different packages. So, like before S3 and S4, there were systems called as S1 and S2, but these did not have the object-oriented programming features. And then later on, towards S3 came up around 1983. This as a informal but simple object-oriented programming features, while there were more advances, and in between there was S plus as well, around 1988, I guess, and then around 1995 there was more formal and strict object-oriented programming, which is the S4 that we are still using. And then more reference-based object-oriented programming came up towards 2014. And recently, last year, there was another reference class called as S7 that was defined. But today's focus will be majorly on S3, understanding S3 and S4. So before diving into that, there is like a base type. So everything that exists in R is an object. But while everything is an object, not everything is object oriented. By this, I mean the objects could be base objects, or they could be object-oriented objects. And to know more about this difference, we can take a look. We can use this package called as Loop that provides tools where we can explore and understand object-oriented programming and then we can try to look at the difference between base objects and object-oriented objects. So, like, let me give a. I hope this is visible. So for this, we need the library called as Loop, and then we will look at the different type of objects. So there is this function called as O-type in Sloop, where if we want to see the type of objects for numbers ranging from 1 to 10, this is base. And then if we want to look at the empty cars, um, this one is object of S3 class. And then if we want to define a function like x minus 2 raised to the power 2, and we want to check the value at 1. So the object type would be S4. So now what is the major difference between these classes? So we can see that the attribute for the numbers, the first example that we saw from numbers from 1 to 10 is none, while if we look at the empty cars, this gives us a class of data frame, that this data empty cars is in the format of a data frame. Like there are different types. Every object has type. Even like null object, it would be a type of null. If we want to look at a complex number, it will give us a class of complex. Then there we can explore different types of these objects. So like if you want to take a look at the numeric type, we have to be careful that there are like one can be like a double or a numeric, but by default, when we look at one, it could be like a double value. But if we explicitly say 1L, it could be like integer and numeric class. So, and if we want to look at the type of factor of x, it gives us an integer because that is what we had looked up. And then we can check if we just check is numeric, is it a numeric? It would result into false. Going back to the presentation, so just the difference between the objects, the base type and object-oriented objects is having class attribute and have base type. So there is a function called as S3 dispatch, so this dispatch would be coming up a number of times in the next few slides, and also some R demo script in the R demo. So this is basically a set of methods that are considered, found, and actually being called by the. So we will look at different examples with this function, but diving more into S3 systems, this is the simplest and the most widely used object-oriented system in R. This is found with the base R base R packages, linear modeling. Such as we also saw the example of data frame. It could be like a summary. And the thing in S3 is that this is informal. There is no explicit class definitions, and it focuses on generic functions and methods and method dispatch, like the process of picking up the right method. I will give a demo about this based on objects on the objects class. So I will quickly run over this theory and then show some examples. So in S3, when we want to like write a function or a class, it is a good practice to start with constructor, which is like a function that builds and tags the object with a class. So here the construction is just adding like a class tag to the function. And the three steps for a good constructor is to validate the inputs, set the class properly, and then it should return a structured object. And here with S3, we can let R decide which function or the method to call based on the class of the object. This could be like a default value that R chooses, or we can tell R what default method we want it to call. And then it's implemented with use method inside a generic function. And then there is a generic class functions, like the default order with which the R decides which function or method to call is based on the generic class, superclass, and then generic default. Okay, let's go back to the demo script. Here, I am going to talk about, in the first part, I'm going to talk about creating the constructor. So let's start by creating a constructor with, like, for a person, we want to look at the name and the age of the person. And here we are also like validating the input, whether if the name should be a character, and if it is not, then we should let the user know that it is not a character. And then for age, we want it to be numeric. And if it is not numeric, we want the user to know that it's not numeric. So we want to validate and also let the user know about what is the explicit uh, type of object that is expected, the input that is expected. So let us try to run this. And then let us create the first object P1, where we want to say that the name of the person is Alice and age is 30, and the person 2, the name is Bob and age is 40. So having done that, let's try to inspect more of the structure for these objects. So if we look at the class of P1, it will say P3 because it's defined using the constructor person S3. And then if we want to look at O type, that is the object type, so it will say that this belongs to S3. And there is another way to check, like if it belongs to the S3. There is a function in Sloop called as S3 class. And then another function that is present in Sloop is like we can check if it's like S4. Because this is S3, it says false. And then in addition to this, if we want to see the internal list of this particular object, we can try to unclass it and try to get it will give us the information that the name is Alice and age is 30 for object P1. Now I had talked about generic methods. So here, let's create print S3 and print dot person S3, these functions. So having done that, we trying to look at this dispatch where we want to know like which method R is picking up. So in the first one, print S3, it is just using the function called as use method. And then here we are just defining it in a different way. that it should just print the name of the person and the age. So let us see how these examples, these print statements look like. So here, this use method is telling us about, is also giving us information about the attribute class, and then in addition to the name and age of the person. Then if we are using another print statement, it just tells us how we have defined the print statement to give us the output as. So it is giving us the output as person name and age. And then this is there. And then this S3 dispatch function, which I had mentioned before. So this will tell us like the different print statements that are there for this particular P1 object. So by default, it is, so here you can see print S3 dot default. So this is R is selecting this particular print statement as the default one. But for print, there is another print function called as print s3 dot person s3. So, but when you're defining the methods, one important thing is that the function names should be such that we don't overwrite the default statements. I mean, like although we can restart our session and get back to the default methods, but in a good practice, it would be better that we don't overwrite the print statement. So that is why I just used different names for defining the print functions. Otherwise, like if I would have instead of this, I would have just used the print dot default. It would have automatically changed my print statement to the way I had defined the print method. So in addition to this, we can try adding another generic. Say I want to look at the summary of this function. So here it's just telling me that it is just the way I want to define the name, person Alice, age 30. Now, in addition, like for the S3 system, we can look at, we want to inherit the properties from the person S3 class. So here I am defining like a structure with name, age, and grade. So now in addition to name and age, we can take a look, we will get to see the grade of that student or the person. So here I am writing another print statement for the student. So in this, there is a call to like a function called as next method, which helps to inherit the properties. So now we have this information. So like we can define another object just using the student S3 class. So we can take a look at these different print statements. So here we have name Clara, age 22, and grade A. And in addition, this has like attribute of class, student S3 and person S3. And if we want to look at the different print methods associated with this student class, so here we can see that S3, with the help of this S3 dispatch function, we can see the different type of print statements that are available for this stu object. That is print default, print.person s3, print.student s3. So this was about constructing using the constructor now, and also defining the print statement, looking at another generic function summary. We can also access the objects of these classes. So this is similar to accessing the object layer from a list. So if I say P1 $name, so that will just give me the name Alice, because that was the name of the person in P1. If say suppose I want to look at the age of the person P2 of object P2, that was 40, Bob age 40. And then if I want to look at the grade of the student in the stu object, we can access it using the $sign. So this is how S3 constructing the object and exploring the S3 is. There are some more examples that we can take a look at for exploring the S3 methods, the functions related to that. Say I want to look at the methods associated or like defined for a generic like mean function. So this will tell us like what are the different like the class, the generic class where where it can be used, like date, delayed array, difference time, and is it visible? What is the source? Is it like a base registered S3 method? Is it a S4 vector? So we get information like this. Then there is another function called as S3 methods class. So this is going to tell us about the generic as data frame, having the class ordered and is it visible and what is the source, base or registered S3 method. So this was about the S3 method generic and S3 methods class. Just like a quick summary, we can take a look at a few other functions for dispatch, like what is the default method that is going to pick up for these examples. So if we look at class of metrics, I want to look at like the first 5 entries. So it will tell me that it's metrics, and then this will be like the implicit class. But if I want to look at S3 class for this, it is going to tell me, it is going to give me some more information, like it has metrics, integer, and numeric. And if I want to look at the S3 dispatch for printing the metrics, it will show me like the print statements, print.metrics, print.integer, and print.numeric. So this was more of like a brief overview for the S3 systems. We can like uh, move forward to S4. Um, but just like a quick thing about the best practices in S3 is to avoid dot when naming the function or the class names, because it might conflict with the base R naming method. And to define like the function names, try to use snake case or the camel case. And as I mentioned, like in the constructor, we want like the function to be in a way that it should like validate and help the user to use the function. And then next method is basically going to delegate to the subclassing. So quickly moving to S4, although like we saw S3 is flexible, but it is kind of unstructured and it can be hard to maintain large code bases. So here comes like the S4, which provides explicit class definition. This has typed slots or the fields, and then there are validity checks, and then there's a formal generic method dispatch. And these can be ideal for complex packages like the Bioconductor packages that we use. So here, like in the next demo I'm going to show is about the features of S4 set, like the set class to define the class and the slots. New function is used to create the object. And then the methods can be defined by using the functions set generic or set method. Here, slots like strongly typed and with the option of like validity function. And let us take a look at the S4. So here, like the person class we had defined in the S3 system, for the S4 system, here we are defining the S4 class. We want the class name. We want the slots. Here we are like giving like a nice structured definition. The slots to be like the name and the age for the person. And here you can notice that the function name should be in the upper camel case, while in the S3 it is preferred that it is in the snake case or the camel case. So let's take a look at this. So we have set the class, and then we want to get the slots. We want to print what slots are present. So here we get the slots as name and age and the type of these slots, character and numeric, because that's what we had defined here in our when setting the class for person S4. And then the slot names, if we just like write the slot names, that's how we get the name and age. Now let us create an object using the constructor new. So S4 system, we directly have a constructor with new function. So here I am giving the name of the constructor, the person S4, name of the person and age of the person. So this will, if I just like print this object S4 P1, so it's going to tell me that under the slot name is Bob and under the slot age it is 32. The age of the person is 32. Now we saw that in S3 we were accessing the data like for the object using the dollar sign, but here we use this at the rate symbol. So like we can say that name of the person is Bob, age is 32. So this is one of the key difference. And then next we can define a method for S4 class. So here, like I'm saying that set generic, and then the method say I want this person to introduce himself. So like I'm defining the method introduce and then the function object and standard generic. This is how it's written. And then we have set this generic, and then we are setting the method that in introduce object person S4, just give me the output as like, hi, my name is the object name and I am like X years old. So just like a very simple statement. So let us try to use this introduce function. So here it says like, hi, my name is Bob and I'm 32 years. So this was about creating, like defining the methods for S4 class. Like the difference between the like structures and the dispatch used in S3. We had the object P1 from S3 class. So if we want to look at the internal structure of that particular object P1, we have name and age. And then if I want to look at the structure for the S4 object, we can like use the str function, and then it gives me like a formal class person S4. This is what we like look at the object definitions for our special object or like the SCE object. Here it tells us about like how you can access it. So it tells at the rate name and then character Bob, age, number, it's a number, and 30, and the entry is 32. So this is how we can take a like this is how the difference looks like for the S3 and S4 objects. We can check whether these the for the validity and the formal class definitions in S4. There is a function called as valid object. Is it like a valid S4 object? So yes, it is S4 object. And then if I want to show the class of person S4, it gives us the information that this has the slots name and class as character and age. So having looked at this, how does it apply to the work we do? Let us take an example of some like from the summarized experiment. I load the summarized experiment library and then say library airway. I want to load an S4 object from airway library, data airway. So like if we quickly look at airway, sorry. So it's ranged summarized experiment. It has dimensions, metadata, assays, row names. So we can like quickly inspect about this data, like what is the class of this airway. It comes from the package attribute package summarized experiment. And then we want to see if it's like a S4 object. Yes, it is an S4 object. And then like slot names, what are the different slot names? It has row ranges, call data, assays, names, metadata, and element metadata. Next, we can look at what are the assay names associated. So we can say assay names and airway. So here, this summarized experiment object has counts as assay names. And then we can take a look at the call data. So here we see that it's a data frame with 8 rows and 9 columns. And then there are different columns like sample name, cells, run, biosample, and then average length. So this another function called as the row ranges gives us the genomic ranges. So like these are the genomic ranges with this has 17 ranges and 2 metadata columns. So this is how we can explore our special object or the single cell experiment object. So now, as I had mentioned, using the at the rate symbol, airway at the rate assays, it's going to give me list of it's going to give me the information that this is an object of simple assays. It has a slot called as data, and the name is counts. And then call data. If similarly, like if we want to look at the metadata, we can use the at the rate symbol again. So that's like a different way of looking at the call data. And the metadata is going to just give me the additional information. Like this is from like the title of the paper, RNA-seq transcriptome profiling, is a for like airways, the how the cytokine function in airway smooth muscle cells modulates. And then there is like another thing to note that like if we want to use the dollar sign, this is not going to work. So if I want to access the assays using dollar sign, it's going to give me null. So like that's not the right way to access S4 objects. So similarly, if I try to use dollar call data, that's going to give me null, or it might return an error. So yes, that's how this S3 and S4 objects work. And back to the slideshow. In summary, about S3 versus S4, we have this class definition in like S3 with it has like a class attribute where you have to give the class attribute through the constructor. And while S4 explicitly has slots, and S3 uses generic dot class method by default, and then the methods used in S4 is the mix of set generic and set method. To access the data, like S3, you can do it in the list style using the dollar symbol. For S4, it's at the rate symbol for accessing the slots. And then with dispatch, like which is the different types of method, the right method, the R would be using is by defining the use method in S3, while in S4 it's a bit more formal through we can set it through like the set generic or the set method functions. And the use cases are more like base R, LM data, linear modeling, or like the data frame in S3, while S4 we just looked at like the summarized experiment example, like for making the bioconductor packages. So yes, that was all I had to share for today's presentation. Thank you.